Welcome back to Seacoast High School's Remote Trigonometry. Once again, I'm Eric Fearing. I use he, him pronouns, and most of my students call me Mr. This is the fourth video in a sequence about our Competency 2 Benchmark 3 using the laws of sines and cosines to solve triangles. This piece is about solving for sides using the law of cosines. The law of cosines is, again, c squared equals a squared plus b squared minus 2ab cosine c. It's a variation on the Pythagorean theorem where we use the cosine of a known angle in order to adjust, because we don't have a hypotenuse if it's not a right triangle. We just have a side across from the angle we care about. That's C, the way this particular version is labeled. So when we want to find a missing side, we need to fill in the side, the angle, and the side across from the one we don't know. So we're going to have a setup similar to this one. We have triangle ABC, where obviously the only side we don't know is segment AB. We're trying to find the length of segment AB. We could call it side little c across from angle big C. And so we've got little a is 29, little b is 13, and we can just put it right into the law of cosines. C squared equals a squared plus b squared minus 2ab cosine c. Remember, this is the only angle is inside the cosine, and the sides are the two legs that are next to the angle, and c has to be across from our angle. That's why we have that matched up. The problem set isn't going to call all of the triangles A, B, C, so you'll have to use different letters. Remember, these are the two legs surrounding the known angle. We're going to always find the other side. So just substituting in 29 squared for A squared plus 13 squared for B squared minus 2 times 13 times 29 times the cosine of 41 degrees equals c squared. And this has no variables in it. It's actually really simple to run through a calculator apart from typing to get all of that stuff. So let's bring a calculator up. You can key it in all just like it is without too much trouble. 29 squared is apparently 841 plus 13 squared gives us a total of 1010 for our first two terms, minus 2 times 13 times 29 times the cosine, check that you're in degree mode, of 41 degrees. All right, so that expression comes out to 440.948. Let's go ahead and call it 400. Well, actually, we don't even need to do any adjustments to that. I'm going to write it down as 440.94 and so on, because I'm going to leave it on my calculator as the full decimal there. That does not give us the missing side. 440 is a ridiculous length compared to 29 and 13. So we still have to take the square root to get c on its own. Square rooting a variable would technically give us a positive or a negative answer, but we know the side lengths are all going to be positive, so it's no sweat. Positive square roots of c squared and 440. To do that on Desmos, just hit the square root, and then remember this answer button down under the 3. We'll fill it in with as much precision as we can get, and good, that one gave us something that rounds up neatly to 21.0. So approximately 21. And that's how all of these work out. There is the possibility that you would have a known angle and two known sides that don't line up the way you want. So here we've got angle A, we know side A, We don't know angles B or C, we know side B. So we have little a, we have little b. Instead of having a side, an angle, and a side, here we have two sides and an angle that is not between those. If you remember your geometry class, your teacher almost certainly told you side-side angle just doesn't work except when there's a right triangle. That's because while here we've drawn it so it looks like it has an obtuse angle at B, there's another version of this triangle which would have an acute angle at B, like we shifted this out to the side. And if we had an acute angle at B and a larger angle at C, we could still have 17 and 10 and 34 degrees. So there are two options. You can still plug this all into the law of cosines, but it's going to mean that you see that you're going to have B, or I guess in this case C is our unknown side. You're going to have something that has C squared and C times some other coefficient. And we can't add those unlike terms together. We could solve it like a quadratic, and then we'll get two answers, but that's way more work than is necessary. If you encounter a problem where you have a side-side angle set up, you know two sides and an angle that is not between them, what you want to do is instead think to the law of sines from a couple of videos ago. Because we know A and A, the sine of 34 degrees is in proportion to the side across from it, we can find angle B, and that will also tell us angle C because a triangle's interior angles add up to 180, and we can work our way around to solve all of the missing pieces. We don't want to use a side-side angle setup in the law of cosines. We always want to favor the law of sines. More of that in the next video when we go on to problem solving and even do some of our first word problems of remote trigonometry. In this video, we talked about calculating a side using the law of cosines. This is the last of our Benchmark 3 Competency 2 videos. If you need any help, you know how to contact me, Google Classroom, Google Voice, or office hours on Zoom Tuesdays and Thursdays, 1 to 2:30. Thank you.